Hey everybody, hope you're doing well. This video is the only one you're going to see here for the shortened week 8 of the fourth marking period. This is going to walk you through how to divide rational expressions. So this is going to continue to build off of what you've learned in the last couple of videos with rational expressions and going to continue to build off of everything we've done with factoring. So if you take a look here at the top right of the screen, little box showing you a couple really basic fractions and how division works if you're doing it by hand. So you notice it's taking 3/5 divided by 7/11. You may or may not remember when you divide fractions, division turns to a multiplication problem. But the way that happens is if you flip the second fraction. So you notice 3/5 divided by 7/11 is the same thing as 3/5 times 11 over 7. That's going to be really important for what we do here because you'll see that this is going to be exactly like what we did in the last video when we multiplied. The only difference is we got to do a pre-step where we have to rewrite the problem so that it does turn to multiplication. So if you look at the steps at the top, in order to divide, step 1, we got to change division to multiplication. To do so, we're going to use the little moniker keep, change, flip. We're going to keep the first fraction the same. We're going to change division to multiplication and flip the second fraction by writing its reciprocal. Keep, change, flip. So for every problem we're going to do here, since we have division signs, we are going to go ahead and rewrite it first using keep, change, flip. Once we do that, we're going to do the same steps we did in the last video. Factor everything, treat it then as one big fraction, cancel everything that we humanly can. So, 2 slides here in this video. Let's go ahead and walk through the handful of examples that I have. So, number 1. First thing I'm going to do, keep the first fraction. So it's again a division problem, so that's why I'm automatically doing a rewrite. Keep the first fraction, change the sign, flip the second fraction. Keep, change, flip. Do that first. Don't try to factor these apart because that's when you end up making goofy mistakes and things don't cancel right and you end up with a mess. Rewrite the problem. Don't be lazy about it. Rewrite it first. Now, once I do that, let's go ahead and factor everything. Top left, I can take a 3y out, and I'm left with y plus 2. The bottom left, I can go ahead and factor the bottom left using difference of squares. They're both square rootable and being subtracted, so it would break apart as to y plus 4, y minus 4. Top right, nothing happens, so I leave it alone. Bottom right, singular term, nothing happens. So now I factored everything. Now I can connect it as one big fraction, and we'll see what cancels out. So, the y minus 4's cancel. There is one other thing that cancels. You have some loose things out in front here. There's a y out front, and there's a y squared in the bottom. One of the y's cancels out with one of the y's from the bottom. Because remember, y squared is the same as y times y. One of those y's would cancel each. What that means is I'm left with 3 times y plus 2 up top over y times y plus 4 in the bottom. And that's my final answer. So you'll see again, it's not that much different than what you have been doing. It's pretty much the same thing as the last video. The only difference is since we see a division sign with our original problem, keep, change, flip, and that'll allow us to go ahead and solve these accurately. So let's go ahead here and look at the second example. Again, division problem. Let's keep, change, flip. All right, now let's go factor. Top left, I could take out a 2x and be left with x plus 2. Bottom left, difference of squares, x plus 2, x minus 2. Top right, GCF of 3, x minus 2 left over. Bottom right, trinomial. So this particular problem uses a little bit of everything here. What multiplies to 2 and adds to negative 3? Negative 2 and negative 1. So again, we make it one big fraction, And let's go ahead and cancel some stuff. So I see an x plus 2 that can go away. I see an x minus 2 that can go away. So up at the top, I have a 2x and a 3. And at the bottom, I have an x minus 1 and an x minus 2. I'm going to rewrite the top just because they're two normal looking terms. It looks kind of weird to leave it as 2x times 3, so I'm going to call it 6x. I'm still going to leave the bottom factor the part. I don't need you to distribute that together. But now I have my final answer. 6x over x minus 1 times x minus 2. All right, couple more examples here. So number 3, let's go ahead and keep. Change and flip. All right, so the top left we have a trinomial. What multiplies to 3 adds to 4. Positive 1, positive 3. Bottom left, another trinomial. What multiplies to 6 and adds to 5. 2 and 3. Top right, another trinomial. What multiplies negative 10 adds to negative 3. Negative 5, positive 2. Bottom right, a little bit trickier just because we have x squared plus x. This is always one that stumps many people here. This is not a difference of squares, mainly A, because it's not a difference, and B, x is not square rootable. This problem, you can take out a GCF of x. If you divide an x out of both terms, you're left with x plus 1. So that's what you would do in the bottom right. Let's connect it as one big fraction. We got several things that cancel. The x plus 1, the x plus 3, and the x plus 2. Leaves me with a final answer of x minus 5 over x. Remember, we don't cancel the x's because the x up top is connected with that minus 5, and you don't disconnect something that's connected by addition or subtraction. You have to cancel the whole thing out in order for that to work, so we leave that alone. X minus 5 over x is my answer. All right, last one here up at the top, number 4. First thing we're going to do is make the second part of this a fraction. Again, visually, especially since we're doing this whole keep, change, flip, this will definitely make sure we have all of our values in the correct spot. So again, I'm going to go ahead, keep that first fraction, change the sign, flip the second fraction. All right, so let's go ahead. The top is the difference of squares, x plus 1, x minus 1. The bottom, the leading coefficient's negative, so I'm going to go ahead and take out a negative 1 to see if that'll help cancel anything out. The whole fraction on the right side, nothing breaks down. The 1's not going to break down, x minus 1 doesn't break down, so that's it. X plus 1's cancel, and x minus 1's cancel. So that's why it was helpful to take the negative out with the denominator of the first fraction. So what that leaves me with is 1 over negative 1. That divides to negative 1. A lot of work to turn it into negative 1, but that actually simplifies down pretty nicely. All right, last question here. What common factor divides out when finding the quotient of the problem that you see there? You can see a lot of trinomials. Quotient, remember, is a vocab word that means find the answer from division. So all it's really asking you to do here is work through the problem. It wants to know what factor divides out. So we don't even need to solve the whole thing technically. We will, I guess, to a point. But all it's asking for is what's going to cancel out once we actually go through the division process. So again, I'm going to do the same thing I did in the other 4 problems. We're going to keep the first fraction the same. And when you copy this, make sure you have all the right signs. Change the sign and flip your second fraction. Okay, so let's go ahead and factor this apart. So top left, so these are all trinomials. Nothing has a GCF here. So we're going to go ahead and use that trial and error strategy for all 4 of these pieces. So top left, what multiplies to 2 and adds to negative 3, negative 2, and negative 1. Bottom left, what multiplies negative 3, and that's the negative 2. Negative 3, positive 1. Top right, what multiplies to 12 adds to negative 7. Negative 3, negative 4. And the bottom right, what multiplies to 3 and adds to 4. 3, and 1. So the question is, what common factor divides out? So what cancels? There's a lot of factors that kind of look the same. We kind of see some things in some similar places here. The only thing that cancels is the x minus 3. So B would be the correct answer here because that's the only thing that cancels out. You'll notice there are a couple x plus 1s, but they're on the same side of the fraction bar. That means they don't cancel. In order for things to cancel, they'd have to be on opposite sides, as we've talked about in the last couple of lessons here. So, as you can see with division, it's very similar to multiplication. Hopefully you see with these 3 lessons here, they all pretty nicely stack on top of each other. Division just takes that one extra step of rewriting the problem as multiplication, and then factoring and simplifying from there. So once again, short graded assignment, a handful of division problems. Take your time, make sure that you complete it, submit it in a timely fashion. We only have a few days of school left, so make sure you're getting this in before we hit the end of the year and before we hit the grading deadlines that I have in order to get everything finalized for the 4th marking period. So if you need anything, have any questions, want some extra help, as always, send me a message on Schoology, shoot me an email, or stop by my office hours on Zoom. I will be more than happy to help you out. Otherwise, thanks for watching, stay safe, stay healthy, and we'll see you next time.